and welcome to the Pure Water Project Las Virgenes Triunfo demonstration facility. My name is Ricky Clark, Public Affairs Associate here at LVMWD. In a few minutes, we'll be taking a look at the advanced treatment process that uses recycled water and further treats it to drinking water standards, creating our own localized source of water. At a time when climate change poses a major threat to our region, the JPA was motivated to create a reliable, resilient, and sustainable water supply. This is the function of the Pure Water Project. The full-scale facility, set to go into operation in 2030, will provide up to 15% of the region's drinking water supply. But until then, our demonstration facility will serve as a resource to educate communities, elected officials, academia, and other water agencies, all while providing our operators with the hands-on experience to become familiar with the technology before the full-scale project goes online in 10 years. At first glance, you may think this is a brand new building, but in a commitment to sustainability and keeping costs low, we actually repurposed the former LVMWD headquarters building to house the new demo facility. Before we head inside, let's take a look at our video, which provides additional context to the Pure Water Project Las Virgenes Triunfo.
For billions of years, the same water has been cycling around the Earth. From this perspective, it is hard to imagine that there can be any kind of water shortage on this beautiful blue planet. Yet almost 97% of this water is salt water. Of the 3% that is fresh water, most of that is locked away in glaciers and icebergs. That leaves just 1% of the planet's water that is accessible and available to meet the needs of an exploding human population. This 1% must quench the thirst of 7.5 billion people today and nearly 10 billion by 2050. And it is not just water for human consumption. From generating power, to making automobiles, to all of the food we eat, water is involved in the creation of almost everything we enjoy. This is the hidden use of water, the water we don't see, that makes our modern life possible. As water passes through our cities and towns, farms and factories, and over natural rock formations, it picks up a host of contaminants that affect its quality. In addition, because water is not evenly distributed around the world, droughts and floods add additional pressure to water-stressed communities. Within the communities served by the Las Virgenes Triunfo Joint Powers Authority, there is no local supply of drinking water that can meet our needs. This means that all of the drinking water for both our districts must be imported, mostly from Northern California through the State Water Project, and this water has its origins in the snow-covered Sierra Nevada mountains. In this system, the water travels over 400 miles, passing through numerous rivers, reservoirs, power stations, and pumping plants, which must lift the water over mountains as high as 2,000 feet. While this water has great value to our community, there is a significant cost and use of energy to transport it from the far north to our region. In addition, drought, a strained delta ecosystem, impacts from a changing climate, potential damage caused by earthquakes, and competition among water users means that we cannot count on a consistent supply from the State Water Project. One of the ways in which we deal with these variations in supply at Las Virgenes is by storing imported water in Las Virgenes Reservoir. It is good to think of the reservoir as our water savings account, which can hold enough water to meet our needs for 6 months in an emergency. During the summer, we draw water from the reservoir and treat it at the Westlake Filtration plant, which can process up to 18 million gallons per day. Too often, we think the amazing journey of water ends at our homes and businesses, where we use it for cooking, cleaning, gardening, and more. Once we flush it down the drain, we don't think of it anymore as something that has value. In fact, our homes and businesses are only the halfway point in our local water cycle. The Joint Powers Authority's Tapia Water Reclamation Facility is the next stop in this cycle. This is where our used water gets cleaned and recycled so we can use it again. This recycled water provides great value to Malibu Creek by supporting endangered fish during the summer months when the creek has very low natural flows. Most of Tapia's water is returned to the community via our Purple Pipe network, where it is used in irrigating our parks, golf courses, and greenbelts that add value to our region. In the wintertime, however, when demand is not as high, much of the recycled water is released into Malibu Creek and eventually ends up in Santa Monica Bay. This precious water, in which we have invested so much to transport and clean, is basically wasted. But does it have to be this way? If we thought of this water as a valuable resource instead of a waste, we open up a whole new world of possibilities. While the water from Tapia has always met EPA standards, new government regulations are now requiring us to clean the water to levels higher than drinking water standards before sending it into Malibu Creek. With this new reality, it is time to rethink releasing this water downstream and losing it to the Pacific Ocean. We now have an opportunity to get even more value out of our local water. Our Pure Water project will add additional treatment processes on top of what happens at Tapia so that this water is ready for potable reuse, which means we can drink it. The 3 new treatment processes, microfiltration, reverse osmosis, and ultraviolet disinfection, have been used for years in places like Orange County to help replenish their groundwater systems and mimic what nature has done for billions of years. In fact, communities around the world in countries like Australia, Belgium, and Singapore have developed similar systems to help recycle their own water. This is extremely safe technology and has provided hundreds of billions of gallons of water to these communities over the last 10 years. In our case, we will send the highly purified water back to our water savings account at Las Virgenes Reservoir. Here, it will meet California's strict regulations for dilution standards and holding times. Having come full circle, the water will blend with water in the reservoir and pass through the normal drinking water treatment processes at the Westlake Filtration plant. It will then be ready to be used again and again in our communities. Eventually, the Pure Water project will provide up to 15% of our water supply. The benefits of this will be immense to our region and beyond. First, that will be 15% less water that we have to import from Northern California. Financially and environmentally, there will be great savings in the cost and energy that was needed to transport that water over such a great distance. It also creates our own local, sustainable supply of water that provides stability as our communities grow and prosper. The Pure Water project is just another example of the Las Virgenes Triunfo Joint Powers Authority's leadership in innovation and sustainability. In working to close the sustainability loop, for years we have been using recycled water for our parks, golf courses, and greenbelts, as well as reclaiming biosolids and converting them to a nutrient-rich soil amendment. In addition, we have an expanding solar farm that is providing huge savings in electrical costs while reducing greenhouse gas emissions. As we do our part in saving precious natural resources, we ask that you do your part in protecting and conserving the most precious of them all, water. Things like collecting the water in the shower while waiting for hot water, turning off the tap while brushing your teeth, and landscaping with drought-resistant plants and drip irrigation systems can save thousands of gallons of water each year. By bringing water full circle and using it over and over again, we are helping to sustain global water supplies by getting the most value possible out of every precious drop we use and reuse again and again.
Now that you've got a better idea of the importance of the Pure Water Project, let's head inside. First, let's take a look at the mural titled, "The Flow of Life, A Journey Towards Sustainability," created by Ventura-based artist M.B. Hanrahan. The mural illustrates the compelling significance of water to every facet of life. Beginning in the natural world, it depicts how this finite resource sustains the earth and all of its ecosystems before continuing its journey through commercial, agricultural, and residential applications. This culminates in the Pure Water Project, where proven, cutting-edge technology produces a vital and beneficially reusable resource inspiring a sustainable future for all life. The mural highlights water's life-giving elemental nature as well as its critical social relevance, in ensuring a thriving future for humans by emphasizing the ingenuity of the Pure Water Project to support human progression while upholding environmental integrity. Educational as it is, the mural also adds a beautiful wave of color to this highly functional facility. Additionally, the artist painted it on polytab before attaching it to canvas and mounting it to wood panels on the wall. This cutting-edge method used by today's muralists will allow us to dismount it and feature it at the future full-scale facility. Now, before we learn about the advanced treatment process, let's first take a look at what inspired it. Nature already recycles the water that we use in our daily lives. The sun's rays heat up the surface of the ocean, evaporating the water and leaving the salt behind. The water vapor, along with dust from the atmosphere, forms clouds which are transported over land by the wind. The water vapor then condenses and falls to the ground in the form of rain or snow. Once on the ground, the rain and the snow that melts makes its way into creeks, rivers, and lakes, which eventually flow into the ocean, where the cycle starts all over again. Humans capture large amounts of natural water runoff from lakes and rivers for our daily needs. The water that we use in our homes and businesses is initially treated to remove unhealthy contaminants that are picked up along the natural water cycle process. Once we use this water, it flows through the sanitary sewer system, is treated at a wastewater plant, and discharged back into creeks, rivers, and lakes. Communities downstream of these discharges may repeat the process before the water finally makes its way back to the ocean. Interestingly, the water that we currently drink has already been used since our planet was formed. It's constantly being recycled over and over again within the hydrologic cycle. Since Mother Nature knows best, the blueprint to reuse the water was already created for us. We simply needed to use it. Advanced water purification expedites the natural water cycle. Instead of discharging treated wastewater back into a creek, river, or lake, it can be treated again at an advanced water purification facility and reused for drinking purposes. For the Pure Water Project Las Virgenes Triunfo, the purified water will be pumped to Las Virgenes Reservoir, where it will be stored for several months and mixed with environmental factors and water from the Metropolitan Water District of Southern California. The mixed water will then be treated again at the Westlake Filtration Plant and delivered to homes and businesses through our distribution system, completing the pure water cycle. Now, the expedited pure water cycle will allow us to close the sustainability loop, creating a much needed local water supply. Now, let's get into the advanced treatment process. First up, ultrafiltration.
I'm Steve Jackson, the water treatment supervisor, and I'm going to kind of walk through the demonstration process for you. I'm going to start off over here with the feed water tank, and this is actually reclaimed water that comes from our Tapia water reclamation facility. It's already been treated to reclaimed water level, and that's what we're focusing on as we work through the different processes to remove any of the stuff that's in the water that comes from the Tapia effluent. And we're doing that in 3 different stages. This is the first stage here. This is our UF filtration, or ultrafiltration. And basically, they're just hollow tubes inside of these larger tubes that are about the size of a human hair, and they're removing all of those suspended solids. You'll notice that we have 3 filters that look all a little bit different, and the reason for that is they're made by different manufacturers, and the reason that we have different filters is because this facility is also a testing spot to help us make decisions about a full-scale process in the future. Each filter that is filtering the water has a turbidimeter that's assigned to it, and the turbidimeter is actually measuring the clarity of the water. That's what turbidity is. And the values that are coming out of the filter are very, very low. And we have set points that are connected to the control system that if the turbidity is too high or it's elevated, it will actually send an alarm and pull the filter out of service. So after the filter takes the feed water, which is the reclaimed water, and filters it, it goes into what's called our filtrate tank. And that water is held ready to supply the RO process when we move to the RO process. Also at the beginning, when the feed water comes in, we're adding both chlorine and ammonia. We're adding the chlorine to primarily disinfect the filters and stuff to prevent biofilms and growths and stuff like that. And then we're adding the ammonia to make sure that we don't end up with free chlorine at any point, because the next step in the process, RO, can't see any free chlorine. So I'm ready to move on to the RO process, if you guys want to follow me. Okay, so now we're at the RO, the reverse osmosis part of the step 2 here. And basically, this is the part of the treatment, the RO system, that's getting things that you can't see in the water. These are items that are dissolved, they're actually in solution. Things like personal health care products, herbicides, pesticides, all the kind of waste that end up in a wastewater plant that you could measure in the effluent or the reclaimed product of the water. So, and the way that it's doing that is after we get the water from the filtrate, we're basically sending it here, and then we're pumping to 3 different stages. So the way reverse osmosis works, just like this whole process, is something that's very common in the water industry, is you have stages, and each stage you're increasing the pressure to get the water lower, what's coming out of it lower. The values of dissolved sodic, you're actually removing them. And we measure it just like with the UF system. We have a control system here that we monitor all of the different points of the system. And the main thing that we use to determine like how good this process is working is what's called a TOC meter, total organic compound. And we know that what's coming into this is at X level, about 6 milligrams per liter, and the RO process is proved by the effluent of it, which is less than 0.1 milligrams per liter. So there's a big reduction. That tells us that the RO is actually removing all of those dissolved solids. And to add to the system's performance, you heard me mention before that we didn't want free chlorine, so we measure for that. We make sure that there's no free chlorine going to the RO process from the UF process, because it can damage the RO process. The other thing that we're doing is we're lowering the pH even more. We're adding acid to lower the pH level to protect the membranes. We're also adding another chemical that's called an antiscalant, which prevents things from fouling the RO membranes in there. Okay, so now we're to the UV process, and with what we've already accomplished, the water gets here, no pharmaceuticals, no personal health care products, a lot of the dissolved things that I had mentioned in the RO process. This system, the UV process, which is actually called UV, which is ultraviolet light, and then advanced oxidation, because we're adding a bunch of chlorine right here. And what's happening is the chlorine and the water that is coming from the RO is hitting into this chamber here. It's called the UV reactor, and we're just dosing it with a lot of UV light and chlorine. And this is a big log removal item. We're getting 6 log removal from this process, and it's basically just disinfecting everything. So anything that was a virus or bacteria that happened to make it through those first 2 tough steps is going to be really neutralized here. It's going to be taken care of out of this process. And basically, this one has a lot of instruments. Most of it is valving to allow the flow to come in the proper direction. And then we also have 4 different chlorine meters, because we're measuring the amount of chlorine that's coming into the contact chamber with the UV light, and then we're also measuring the effluent, what's coming out of the process. And we're not just measuring chlorine there, we're taking another measurement called UVT, which is the main way that you get credit for your UV disinfection, is your UVT values. So any number that's close to 100, and it's just a raw number, what's called UVT, is a good number. So our effluent typically runs about 99.8% on the UVT, and the influence about 97%. Another thing that we're measuring at this point, because any kind of disinfection log removal that you get, no matter what it is, whether it's free chlorine or chloramines, it doesn't matter. You have to measure the basic parameters of the water. So we're looking at the water temperature, the water pH. Those are all items that are important in the calculation for your CT log removal. And after that, the water comes out of the system and it's ready to go, ready to be set up for tasting events.
There you have it. It is these 3 additional treatment steps that will turn what was once on its way to the ocean back into pure H2O. This water is so pure, in fact, that it is considered aggressive, as it has not yet been fortified by the necessary minerals. If you were to drink too much of this, it would begin to leach those minerals from your bones, making them weak and brittle. This is why the pure water will first be sent to the Las Virgenes Reservoir, where it will mix with the treated water already there for about 2 to 6 months before being put back into our distribution network and delivered to our customers' homes. I hope you've learned something new about how the Las Virgenes Triunfo Joint Powers Authority is doing its part to meet the moment and ensure our region has a reliable water supply to continue to support our communities and the people, businesses, and the flora and fauna that live within it.